Welcome to Chapter 2, Approximation of a Function. In scientific computing, many mathematical problems cannot be solved exactly using analytical formulas. And instead, we use numerical approximation and methods to estimate solution. These techniques allow scientists and engineers to analyze complex systems using computational algorithms. In this chapter, we will explore numerical techniques used in approximate function, solve nonlinear equation, estimate derivatives, and analyze experimental data. These methods are widely used in engineering, physics, simulation, and physics experiment and data analysis. After completing this chapter, students will be able to explain the need for function approximation in scientific computing, apply numerical methods to find roots of nonlinear equation, approximate derivative using numerical differentiation, using interpolation and curve fitting to analyze data. These skills are fundamental for solving real-world scientific problems using computational tools. Many scientific problems require solving equation of the form f as a function of x is equal to 0. The value of x that satisfies this equation is called a root. Several numerical methods can be used to find approximate roots: bisection method, a simple and reliable method that repeatedly divided an interval to locate the root. Second method uses two previous approximation to estimate the slope and converge faster than the bisection method. Newton-Raphson method, a powerful technique that uses derivatives to rapidly converge to the root. Each method has advantage depending on the problem and available information. In many practical situations, we do not know the analytical expression of a function, and instead we only have discrete data points obtained from experimental or simulation. Numerical differentiation allows us to estimate the derivatives using these data values. Common methods include forward difference, use value ahead of the point; central difference, use value on both sides of a point and generally provide better accuracy. Extrapolate difference combines approximate to reduce numerical error. These techniques are useful when analyzing experimental or tabulated data. Interpolation method estimate unknown values between known data points. For example, if temperature measurements are recorded every hour, interpolation can estimate the temperature at intermediate times. Common interpolation techniques include linear interpolation, polynomial interpolation, spline interpolation. Another important technique is the least square approximation, which fits a curve to experimental data by minimizing the total error. These methods are widely used in physics experiments, engineering measurements, and data science applications. Random numbers generates are important in computational simulation and statistical modeling. They are used in applications such as Monte Carlo simulation, statistical sampling, uncertainty modeling. Random numbers allow scientists to simulate complex systems that involve randomness or uncertainty. Please take notice while studying this chapter. To perform well in quizzes and assignments, focus on definition of numerical approximation methods, the purpose of each technique, differences between root finding and interpolation methods, practical application of numerical approximation. You'll often be asked to explain the reasoning behind numerical methods rather than only presenting final answers.